You don't got to take notes on this one. It's the same idea. I just want to show you how to use the Khan Academy stuff. So a function is shown in green. So f of x in green. The sliding purple window. Ooh, look at this. Does it slide? Yes. The sliding purple window may contain a section of an antiderivative. An antiderivative, hopefully I explained it in class, but it's just what comes before the derivative. So if you have f of x, you take the derivative, you get f prime. Well, the regular f of x is the antiderivative of f prime. That's all that is. It's going backwards. So the sliding purple window may contain a section of an antiderivative of the function. Where does the function in the sliding window correspond to the antiderivative? So the original, you can think of this as the original function. Drag and select, or drag the sliding window to the correct region to indicate that there is no solution. So here, I'm going to say that the purple part is the original function, and the green is the slope. So here I have like a slope of 0, and it slowly gets more and more positive for the slope, and then it slowly goes back to 0. In this part, I guess this was a bad first example just because here it's saying the slope is 0 for between 1 and 2. So like if I line this up, yes, the slope is 0 here, but here the slope gets positive, but the green part, which would be the derivative of the purple, it doesn't correspond, and there's actually no place that corresponds. So I'm going to say no solution, and I got it right. Of course I got it right. Same idea. So the purple part is let's say it's the antiderivative, so I'm going to say, the way I'm going to think of it is, the purple part is the original function, and the green part is the derivative. So I have a positive slope slowly getting towards a 0 slope, and then immediately it jumps to a constant slope. So positive slowly going towards 0, positive going towards 0, maybe, positive, and it's going towards 0. Then there's a corner, so it's not differentiable. That's open circles. And a slope of, what is this? 2, 3. So rise 1 over 2, 1/2. And look at that. There's a slope of 1/2. Hopefully this is making sense. Yeah. All right. A function f is shown in purple. The green sliding window is the derivative. All right. So the purple is the original. Green is the derivative. So I'm looking for a derivative, a slope that goes from a slope of 2 all the way down to a slope of 0. So it's gradually changing. Slope of 2, maybe this is it. Look at this. Slope is positive, and it's slowly going towards 0. So I have a positive value for the slope, and it's slowly going towards a slope of 0. And then, oh, this one is a negative slope, and then slowly going towards 0. Here we have a negative y value, but it stays a negative y value. So that doesn't work. What if I moved it? This would be negative. I don't think there's any spot. I'm just going to check. I'm going to line it up and check. Here, the slope, the green, remember the green is the slope because it's the derivative. It's saying a positive 2 for a slope, and then going down to 0. Well, I already have a negative value for the slope on my purple, so that doesn't work. I think this one's no solution. There's no value where it starts out with a positive 2 slope, right? Because green is the derivative, and it has a y value of positive 2. This part maybe starts out at positive 2. Hopefully you can see that. This part starts out 2, it goes to 0, but then it jumps to a negative slope, which also goes to a slope of 0. This is just a negative slope that stays constant, so I'm going to say no solution and continue on. Sweet. Let's see. A function is shown in purple. The sliding green window may contain its derivative. So the regular function is purple. Green is the derivative. Make sure you're reading that because it's important. All right. If green is the derivative, I'm looking for a slope that's constant at -1. And then at some point it jumps and goes from a slope of -2 going to a slope of 0. So let's just line it up and see. Here I have a constant negative slope, That's good. And then it jumps, what is this slope? 1 over 2. Then it jumps to a constant slope. This is not a constant slope. This is a slope going from -2 becoming 0. So that doesn't work. I want a constant negative. Oh, maybe this. Constant negative slope. Yeah, that's this. Okay, that corresponds. And then, well, the slope here is negative, but it's gradually becoming less and less negative, gradually going to 0. So I have a negative y value for my derivative, gradually going to a y value of 0. I think this is right. Let's just check another interval. Here I have a negative slope going towards 0. This is just a negative constant slope, so that doesn't work. Here I have a slope of going from 0, slowly more and more negative. On my green part, that would look like 0 and then getting more and more negative, so that doesn't work. No, I think it was this. What was it? Here we have constant negative slope, so a constant y value for the derivative. And then here we have a negative slope gradually getting closer and closer to 0. Negative slope gradually getting closer and closer to a y value of 0. Okay. Yep, let's see it. Let's see it. Okay, let's practice again. Let's do one more. Function in purple is f. Green is the derivative. Where's the function sliding window? Okay, so I'm looking for a slope that starts out negative and goes towards 0. This slope starts out as positive, actually starts out as 0 and gets more positive, so that doesn't work. I'm looking for a slope that's negative and gets more closer and closer to 0. So this starts out at 0. Nope, that doesn't work. What if I start it here? Here I have a negative slope and it's getting closer and closer to a 0 slope. I'm looking at the slope for this. Okay, that might work. Let's see, let's line it up. So I start out with a negative slope and it gradually gets to a slope of 0. So I start out with a negative value, gets closer and closer to a value of 0, a y value of 0. And then I have a positive constant slope. Is this 1 over 1? Yes. So I have positive constant slope of 1. This is the correct answer. Cool. I'm gonna end the video there.